In PSIM software, there is no direct way to read an Excel file. However, there is an indirect method for reading tables from Excel files. This indirect method can be used to read an Excel file if you are working with data that can be expressed in tabular form. The lookup table, which is a PSIMS block, is used in this method. We will need to open the library browser to add the lookup table to our schematic. You can search for a lookup table here. Choose the simplest version of the lookup table. Place this model on the grid by dragging and dropping it. This block is also available in the Elements tab. To do so, head to the Elements tab, then to the Other section, where you will find the lookup table in the Function Block subsection. This is the lookup tables icon. To open the parameters window for this block, double-click it. This block contains two parameters. The first is its name, which can be changed to any value and has no effect on its functionality. The second parameter is the name of the table file that this block will read. The table file extension should be of the TBL type. As a result, we will need a table file that can be passed to this lookup table. For this purpose, I use the Irradiance data of a single day stored in an Excel file. This is the actual Irradiance data collected by the Irradiance sensor between the hours of 8 am and 5 pm. A total of 40,751 Irradiance samples are recorded against computer time for each second. The graph of Irradiance versus sample number is shown in this figure. Only data of the integer and double types is processed by the lookup table. As you can see, the data in the time column comprises colons and letters that lookup tables cannot understand. Therefore, I have replaced it with integer values ranging from 1 to 40,751. The column headers such as computer time and irradiance have likewise been removed from this file. Here we will also understand how lookup table works. There is only one input node and one output node in the simplest version of a lookup table. We provide the index at the input node, which is a number between 1 and 40,751. It could be different in your situation. At its outputs node, the lookup table searches for that index and provides the irradiance value against that index. For example, if I gave the lookup table 12 as an input, the output value would be 364.38. Our data is now ready to be fed into the lookup table. But as you can see, the Excel file extension is XLSX, whereas the lookup table wants a TBL file. To convert this file to TBL format, first convert it to CSV as indicated on the screen. Then close the Excel window and open the CSV file in Notepad or Notepad++. This is how your data will now appear. Click File, then choose Save As option to save your data in the TBL format. Select all files from the Save As type menu. Name the file with the TBL extension as seen on the screen. Close the Notepad after pressing the Save button. Now you can notice in your folder that the file type of your saved file is TBL. Put the same name with extension in the file name parameter of the lookup table in PSIM software. Once you close the lookup table, it is ready to be used. I have added the simulation control to the schematic and will run the simulation for 1 second to test the lookup table. I am using the math function to provide input to the lookup table, which is found in the Sources section of the Elements tab and is the type of voltage source. The math function has 3 parameters, the first of which is its name, which can be any value. The second parameter is the mathematical expression you want to use. I'll use the expression 40,751 times t, where t is the simulation time. Note that if the input value or index is not present in the table file, the interpolated result will be provided by the lookup table. T start is the third parameter and it determines when your expression should begin running. I am going to leave it at its default value. Finally, voltage probes are used to observe the lookup table's input and output waveforms. I am going to run the simulation now. The index increases linearly from 0 to 40,751 as shown in the graph, and the irradiance curve matches the graph as presented in the Excel file, indicating that our lookup table is functioning well. Now I am going to put this irradiance curve to the test on a P&O based MPPT system. For this purpose, I have considered a 3x2 PV array connected to a boost converter and a resistive load. The PV array has an 1800 watt rating. The P&O code is stored in the C block, which serves as a controller. The duty ratio step size was set to 0.05. I utilized this label to deliver one irradiance value to all PV modules, and therefore used only one voltage source. While you can use distinct voltage source for each PV module, like I did for temperature. First, I'll run the simulation with constant irradiance and temperature, that is 1000 watt per meter square and 25 degrees centigrade. Array power is indicated in red and array voltage is shown in orange in this figure. The PV array is working at 1800 watt and 106.4 volt, which is the maximum power point as can be seen here. As a result, our circuit appears to be in good operating order. A detailed simulation of this PV system has already been performed in a separate video, which is linked in the description. The irradiance profile is now enabled and the simulation is run once more at a constant temperature of 25 degrees centigrade. You can see that array power follows the irradiance curve if you look at the irradiance and array power graphs. The power of PV array at 800 watt per meter square is about 1450 watt, which is approximately equal to 0.8 times 1800 watt. The same approach can be used to create a temperature profile curve. This was a tutorial on how to use PSIM software to read tabular data from an Excel file and use that data to build irradiation and temperature profiles. If you have any questions, please post them in the comments section. Please subscribe to my YouTube channel. See you in the next video.